So we've added these lights in and everything there is okay, but it's time for us to kind of start getting these subtler, smaller details going as well. So the first thing I'm going to do is I'm going to show you a mode called Visualize Reflections. Now this is how my world currently looks if I was to look at the reflections in my scene. You can see that if things are on my screen, it can map out a reflection based on screen space, but the rest of the world is barely touched. Now the reason I'm showing you this is that any reflective or any potentially reflective surface in the world currently doesn't know what to reflect. So it's a good idea for us to go ahead and add initially a skylight. And I'm going to set the skylight to be set to an intensity of about, I'm going to call this 0.75 on gut feeling. And it's going to look weird at first because it's going to illuminate everything, but I'm going to click build. So with the skylight built, I'm now going to click on here again and go back into reflections view. And you can see that this is now how the reflections across the scene will look. And you'll notice that while these are accurate for outside, they're not entirely accurate for the interior. That's okay. It still gives us a little bit of a shine for the fallback in the event that we haven't got reflections set up correctly. But let's get them actually set up correctly. So I'm going to go here and I'm going to type in the word reflect. And you can see that we have three options. We have planar reflections, box reflections, and sphere reflection captures. Essentially, wherever you place these in the world, so I'm going to put one here just as an example. If I drag one into the world and I go to my reflections view, you can see that any surface that is in this area is basically casting a reflection of the image from the very middle of this actor. And you can change the offset of this actor using the capture offset functionality. But basically, it takes a 360 image at this location, and then anything that this overlaps then has that image, which is a good way of faking reflections without having to dynamically capture it from literally every sequence across your map. Now, if I look at how this looks in the world, you can see that there are some kind of subtle effects that start kicking in. Things like my TV can now more accurately reflect the rest of the world. This over here is going to start getting some nicer bounce lighting kind of appearing on it. Generally, areas are going to start coming out nicer. You are going to get artifacts though. For instance, if I put this here, and this is casting a 360 reflection from that location onto everything, then it's getting red bounce lighting coming from this location. So because of that, you want to shrink these down. There's a bit of a balancing act between finding like a good number of reflection capture actors and finding like results that work well that aren't completely covering your map in reflection capture actors. I'm going to put one over here by default towards this general part of the room because it's a bit darker. I'm going to place it up because I figure that's probably going to be a slightly nicer area for it to bounce in. I'm going to switch to my reflections view as I do this. So you can see that as I drag it, it starts blending the reflections at a certain point as these two kind of cross over one another. And you can control how that fall off actually works between the two as well if you're using cube ones. But otherwise it's just a linear fall off in a standard spherical reflection capture actor. So I've put this here and I've put this here, but I'm going to set up this front area slightly differently, and that's because I really want to make sure that in a night scene, it's not so apparent in a daytime scene, but in a night scene, I want to make sure that this glassway would reflect the room perfectly. So to do that, I'm going to drop in a box reflection, and I'm going to place it in the center of this little, actually no, just in front of it, there we go. I'm going to place it there, I'm going to lift it up, and I'm going to essentially place it in the middle of that window. And you can see that the box reflection capture actor is huge by default, so I'm going to scale it down a bit. And it's now... Actually, that's probably still too big, so I'm going to go... There we go. So that's going to capture the room reasonably nicely. Because I want to be safe about where the reflection is getting captured from, I'm going to move it a little bit in front of the door. So to do that, I change the capture offset. And when I go back to lit, I can see, might be a little tricky to see, but you can see the red reflection in the window just there. That is this couch and chair just here. They have a nice reflection now that kind of accurately represents how far they are from the door. So setting that actor in that exact location was pretty important to get a good result. Again, I can now go back to reflections, and I can see that there's still a couple of holes in my environment. This is still blue because the skylight is blue. So I'm going to get this, and I'm going to just move a couple of these into these areas, but I'm going to shrink them down as well. 250 seems like a reasonably good value. Push it towards the door. There we go. And I'm going to do it over here as well. And this now gives us reasonably good reflections across the room. So with the reflection actors now all in, we've got a skylight, we have our point lights casting general light into the scene. It's a good idea for us to start looking at some of the other things that are going on that can often be kind of easy to miss. The first of those is light map resolutions. So I'm going to be upfront about this. There's a slightly confusing element of Unreal where we refer to light map resolutions in two different ways. So when we're referring to a light map resolution of a 3D asset, a higher number is going to give you more accurate results. I'll explain that more when we're looking at objects, but essentially when we're casting light onto objects, we're baking that lighting information into them. And on a 3D object that's been added, the higher the resolution, the more light is being baked in because it's like a bigger texture that stores the lighting. Now, it's different when it comes to geometry, and that is that the lower the light map resolution refers to how much of a space there kind of is between light map texels. It's a little bit confusing, but all you need to know is that when you're doing geometry, if you're getting results that aren't quite as accurate as you would like, it's highly likely that it's because your light map resolutions are a bit too high. Now, as you increase the quality here, you will have a bit of a trade-off in that your map file size will get larger, so you need to be aware of this. But I'm going to grab these areas along the roof, and when I look at them normally, you can see that we're getting some weird shading kind of kicking in here, but this isn't absorbing it. And I'm going to set my light map resolution to 16, just as a test. I'm now going to build lighting. And you can see that now the lighting's built, we're starting to get a more accurate collection of this ambient occlusion being baked in here. Again, if I look at here and here, you can see that there's this weird line that kind of cuts between the two surfaces. And there's a couple of ways that we can fix that. It's largely because this area here is 32 and this is 32, but the others are 16, so they're blurring their light across them kind of a bit more. I'm going to try changing these to 16 and see what my result is. While I'm at it, I'm actually also going to just generally go through some of these areas and see if I can just increase the resolution just in a few of these areas to get some slightly better results. This is one of those things that because it's ArcViz and I know we're trying to keep, it's going to look as nice as possible is really the aim here rather than efficiency and file size. I'm going to set these to 16 and kind of go from there. Usually I'd be a lot more careful. So with this built at 16, you can see that a lot of the artifacts that we were getting from these lines are now missing. That's a lot nicer, and we have a significantly better environment to work with, which is pretty good. And if I go to here, you can see that that's all come out quite nicely. And I'd say we're probably good for this first area. It's probably time for us to really start looking at doing some post-processing. So I'm going to hit save, and I'm going to save this as my final version of demo map post lighting. And in the next section, we're going to start covering the basics of post-processing within Unreal Engine 4.